For this topic, we'll be looking at organizational roles for data analysis. It'll let us explore the developments of the types of people and organizational structures that are evolving to really utilize data. There are four objectives here. First, we'll look at the differences among the different types of analytic jobs and the skills required to fulfill them. We'll be looking at how global companies are setting up to utilize all of that talent. We'll look at four different ways that analytics add knowledge and deliver value. And lastly, we'll be looking at the organizational culture and quality challenges to gain insights from all that data. Data analysis, it's the ability to tell a story that gives insight to a problem. So the data, of course, are necessary, but not sufficient to get value out of it. You're going to need the people, the tools, and the technology to actually get insight from that. And that's really what the key objectives are for the new world of analyzing the data. And there's different types of roles that we're seeing emerge in most organizations to deal with this. The first, business analysts, they've been around for a while now, and they can be in a variety of roles in organizations. Maybe you've been in one of these roles yourself or had a business analyst assigned to your team. Often they're looking at the different business processes that are needed to either collect data or to make sense of the data of where it's coming from. They might be focused on helping to do something productive with the data by coding it or otherwise making it available to different people in the organization that need it for different ways of looking at their function. Those business analysts are becoming increasingly important in this big data economy, and they're consistently now being knitted up and partnered with data architects. Data architects are usually the role that are a bit more technology focused in creating the systems to have access to the data. A serious conundrum now with all of the data being available to companies are where can the data actually be located? Increasingly, it's not going to be on site in the physical location where the workers are. It may be something virtual in a cloud. So a real analysis has to be done by a data architect to understand the latency, the delay of access that the systems need to have to that data. This is an age-old problem even when the data was in-house, often on servers, and in some companies they are still doing that today, but it becomes increasingly complex when it might be a mix of those environments. So they may have some data stored locally on a machine and others that are virtual in a cloud. Many factors come into play here about making that data available by systems that might need access to multiple data stores all at once. So the data architects are going to help us solve that. Now, our data engineers are going to actually be making sure that once that data is located wherever it's actually stored, that it's structured in a way that we'll be able to utilize it. So a data engineer is going to be doing testing on making sure that the appropriate elements are available for different functions in the organization. So if I'm in customer service and I need insight about different types of customers that are buying my products, I know that the data engineers are going to be the ones to help me make sure that the right insight that I need, such as what they bought, when they bought it, how much they're buying it, is available to me. But it's ultimately the data scientist who's going to help me query that. So if I'm a manager or a leader, I might actually have a data scientist now on my team. And the data scientist is going to work with me and my business function to frame up the kinds of questions that I need to have answered and appropriately access that and form it into a way that I can interpret it. It might be a visualization, it might be a report. But you can see this new team of all of these different roles working together to provide those insights to modern companies today. What does a data scientist look like? This is becoming a really hot topic in a lot of labor markets around the world. These skills are very much in demand. IBM says it's really going to be a talented person that uses the scientific method to solve business problems. So in going and asking that question, such as, what have my customers bought and how often, they are going to have the skills to appropriate methods to go in and look at that. They might be looking at it across different types of customer segments or even seasons of the year. They should be skilled in machine learning or artificial intelligence because the volume of the data and the insight that we might need to answer that question has become increasingly complex. So they should feel comfortable be looking at the data and seeing patterns that we can use to make that decision about what they would buy maybe next season, an easier one for having insight. And lastly, they should be able to work across all those other roles, that is with the business analysts and maybe even across people on the team, such as product managers or brand managers that have additional insights that need to come to the fore to completely answer that question about who are my customers and what are they going to buy next. So they've listed some types of skills that you're seeing increasingly important. Data analytics skills using tools or using languages such as R or Python, increasingly very, very important. They're able to manage large data sets for those inquiries that we are talking about. And they're able to sort of optimize and look at how efficient it is that the models that they're building are for me to interpret and also for the business maybe to use if I'm turning the model over. And we'll show you some examples of what I mean by that in the coming slides. So it's a very new set of talent and skills that are in really high demand. A recent report from Forbes showing that data scientists and analytic managers are one of the most rapidly growing job skills and sets that companies are looking for. This data, I think, is more focused in the US, but you're seeing these trends really globally now for these labor pools, especially in cities that are standing up these kinds of data centers, such as Tata, which we've talked about in a prior session. Now, the data scientists are definitely very much in demand, and it's growing very quickly. So this chart is showing the growth of data science and engineers in terms of the labor market. But what's not to be lost is that these skills, an effective analytic acumen, is being expected in a much broader set of roles in companies today. So you can see some really traditional roles, maybe even some surprising roles, such as HR manager, that are increasingly being expected to have some analytic focus and background. And that's because the types of data that are being available and the need for these kind of analytic insights are growing across all of these roles. So even in HR, certainly in finance, you need to have new skills to understand how these things work. And you need to be able to partner with these folks that are in these new roles to actually make sense of them. So it's a really broad set of skills that are being impacted by these trends. We can see that a bit more clearly on this analysis that was done by PwC to show again that, yes, the data science jobs that are needed across a variety of industries are increasingly important and growing. But what's more important is the analytic enabled jobs, which are very traditional jobs. They say in this report, these jobs that you see here, the growth and need for analytic skills, it's really across the full C-suite in an organization, into functional line managers and the like. And you can see that the growth there is significantly higher. So you don't necessarily need to be a data scientist to find this important. In fact, almost all roles in organizations will increasingly have some part of their role or function being affected by analytics, and they're going to need to be able to understand that. So the analytic enabled job growth is far outpacing that of even the deep data scientists. Another way of framing that is this talent is growing increasingly and really rapidly. A quote here out of CFO for Mindtree saying that there are a very limited number of people who are really skilled in artificial intelligence just 5 years ago. The question is not whether we have these skills, but how quickly we can ramp up. Again, to highlight the new development that Tata has stood up, this Insight and Quants division to really focus on providing these kind of analytic tools. So it's a global phenomenon and a very pervasive phenomenon that's affecting most roles in organizations today, to have a basic analytic acumen. Just to highlight this a bit more, the different types of insights considered critical to helping the C-suite, they want predictive insights. So this is the number one thing that top C-suite executives are saying is we really need help to look at the trends of the future. We want to know what's going to happen next, and again, maybe even how to optimize those choices for our companies. They want to be able to make more effective decisions and avoid missing opportunities. This is what they're seeking knowledge for, and that's what all those roles that we talked about should be coming together to answer those questions so they can make better decisions. Another way to look at what they're seeking knowledge in is a 4-dimension or 4 levels of maturity around how knowledge is developed around the analytics. The entry level and most familiar is that data provides information. But that comes in many forms and has been around for a long time. It's the lowest level of maturity is to just have some kind of information that is some kind of knowledge about maybe what customers bought, for example. The next level is to mature that is into some kind of an insight. An insight should be able to help detect patterns. So if I'm not just having a satellite, for example, that's looking out into the universe, but at an insight level, I'm able to have the satellite image that it's detecting in the universe is something has changed. So that would be a level of insight that something is different. So that's much more mature than just having information. The next level of maturity is really to having an indicator. And that is to start to combine that knowledge so that you can not just detect change, but detect important changes. So an example that is happening now in the many medical areas is being able to look at an image that is having a machine looked at an image, a machine learning algorithm, and detect a disease state, something that might be missed by a doctor, even a trained doctor or a set of doctors. These machines can do much more quickly and be more accurate in some cases. And that would be an example of an indicator. So I detected change, but I've been able to detect an important change using these tools. Culminating the very upper echelon would be the level of an instrument. An instrument should be able to combine lots of indicators and actually have make sense of very complex data. So you look at something like global warming, which is having all kinds of impacts on the environment. These instruments should really be able to hone in on the most important changes that are happening and then help decision makers make choices around that. Even to a business, an instrument level shouldn't just tell you that you're out of inventory, but an instrument is going to be able to help solve how to ensure that you have a quality supply that is always going to be able to come into the company. And so that's really a much higher level of intelligence that provides much more value when they can be delivered or developed. And these machine learning and all the big data is coming together to do that. Now, it's not just enough to build these levels of maturity for the analytics. We also need to make sure that the actual company that we're developing is able to utilize them. And there's 4 key levels of maturity in an organization that you can look for. The first is that the leaders are super passionate about making decisions based on data. If you don't see that, then you're probably not building an analytic culture. And it may be, you may have all those other things we just talked about in place, but if you don't have a culture that's committed to utilizing the analytics to make decisions, it's not going to go anywhere. The next, of course, is that they have the appropriate talent to work with those tools and analytics and all those methods, much like having the appropriate data scientists or data architects on staff to do something important with the data. And the leaders and managers are willing to act on the results and manage in a meritocracy, meaning that they appreciate, they have a reverence for what the information coming from those data streams mean, and it has an impact on their next steps. Now, this is a balance. It doesn't mean that their own intuition and talent don't come into play, but you're seeing increasingly cultures that get this balance correct have all of these components. I'll show you that in just a few moments with some illustrations. Culture and quality challenge is really significant. A recent survey, again, a broad swath of C-suite executives saying, it's got to have the level of quality and comprehensive insights around the data. This is really the challenges that they're facing, and it's a cultural challenge. If either they're lacking the tools or the talent or the processes to actually utilize that, that's really the big concern. So without all that coming together, it's a real challenge. This is a nice quote to say, it's not just to have, in this example, the talent, the data scientists. You need to have them in the right spots in the business. You need to be able to knit them up into the organization so that they're able to add value by working with people that have those functions to help them make better decisions, such as what will my customers buy next and why are they buying those things? So you really need to have a balance for these to come together. It's not just enough to have one without the other. Some good illustrations of that in a recent Harvard Business Review article. They say you can look for where these data scientists might be too independent in an organization or too embedded. A recent example arose where if the data science group is so independent, the risk is that they're looking at all that data and they're coming up with insights that are technically sound, but they're not going to be helpful to the business. This particular article illustrates an example where a large rental company for cars at airports, they commissioned a data science group to help them solve the supply of cars that they were going to be needing. But once the data scientists turned the dashboards and intelligence over to the business, it was so complex that people actually at the airport were unable to use it. And so they just went back to what they were doing. So that was a big effort to build those insights, but it was too complex for them to use. So this is a balance. Now, it can also go the other side. It can be so embedded in the business that sometimes those analytic groups are not actually helping the bigger organization. So an example in this particular article was that the analytics were helping a functional manager buy new cars for that same rental company because effectively it was easier for them to manage new cars. New cars break less, and so there's less headache. But it wasn't really a cost savings for the company to do that, but that's what the analytics was supported because the data scientists were so embedded in the business, they're tempted to then lean toward the desires of just that one functional unit. So indeed, it might be better to buy new cars, but it might not just be for cost savings reasons. It might be for customer and competitive reasons. And really, a good balance would be to look at all of those things in concert before either having a model too complex or a model that's too biased actually put into place. Another one is around the culture of the organization. So these examples around having too strong of a culture around analytics might mean that you're just blindly following what the analysis suggests without really understanding the bigger picture. So if those things become so embedded to just defy common sense, you might really lose business. The example here, a large financial company that were selling insurance products implemented a quota for their salespeople to have a certain number of sales calls every year. They ignored the fact that their most successful salespeople, they needed to make fewer calls to their bigger clients. So you're really burdening a very talented sales pool that are bringing business from the bigger clients and forcing them to go out and have more sales calls. They became very disgruntled and actually left the company. Now, the model was right. It was more productive en masse for their sales force to make more sales calls, but maybe inappropriate to be applied across the board. And they lost talent as a result. On the other hand, you become too focused on just going with the gut and ignoring the data. That's probably not what we want to have either. It's a balance. And finally, to illustrate, sometimes these tools and these models can become either too complex or miss something because they're too simple. An example, again, back to the car company that I illustrated, when the models are very, very complex, you may not be able to get the insights that you need in a timely fashion. And the business just doesn't really know what to do with a model that requires looking at so many different elements. On the other hand, if it's too simple, you could really miss something that you really should have taken into account. Let me illustrate the simple side. I think that's just worth a moment. An illustration was that a consultancy was hired by a very large retail chain looking at how to attract more customers to their stores. In other words, what days of the week should they offer sales? The analysis came back that the retailer should offer sales on weekends and holidays. Well, that's because the data were collected and it basically just confirmed that more people were going to the stores already on the weekends and the holidays. It was a very simple model, basically just confirming that there's more foot traffic on those days. It doesn't really answer the question of how do they attract more foot traffic into their places of business. A better question might have been, what types of sales or promotions need to be offered and at what times to attract new customers into the stores. But because they didn't ask that question, they were fooled to a really simple solution to basically do what they're already doing. So it's a balance. So the methodology that's actually employed in these, whether it's too complex or too simple, we need something that's in the middle. The recommendation really, and you're seeing more companies move to this kind of a structure, is you need some kind of an analytic nerve center. So this might be the very top talent in the example of data science to really have a centralized, a small team that's built around them. And maybe that person has that group is led by a chief analytics officer. These titles have different names in different industries, but basically somebody that is a C-suite executive that's leading these kinds of teams. But you maybe then embed generalists into the business functions. So it's more of a matrixed or a network solution. That way the functional leaders do get the insights that are really helpful with working with a data scientist, but the data scientist is also reporting up into a larger knowledge center, a nerve center around analytics to make sure there's a check and balance, that they're not becoming too biased and that their methodologies are sound. Finally, of course, it really helps that you have sort of a champion, challenger kind of mentality. That is, the trust or gather those analytics, look for the insight, championing that. But also, you should feel free to have a culture to challenge the results and have a dialogue around that. That way, there's really a balance in decision making. So the takeaway that we've seen here is that data analytic decision-making skills are really in high demand, but they're across a broad spectrum of jobs and roles. Executives are seeking greater decision support far beyond just having the data available. They're really looking to have an increase maturity, building up hopefully to instruments, so that instruments are helping them analyze complex trends about their company or their customers, and then helps them take action. And finally, the challenge is, how do you shape that organizational culture? Companies that get this right are striking a balance about positioning that analytic talent functionally aligned in the business in the right places, and then helping them cooperate with the business leaders to actually get the most value out of all that information and data that they have today.